Well, let me talk a little about format of our event. So, well, actually, it should have been conducted many months ago, but unfortunately, due to some circumstances, the event was postponed. So we're finally conducting it now. Format of event is the following. I will just show some examples on running Java workloads in cloud, and if you want, you can do it in parallel together with me. If you don't want, you can just take a seat here and listen. If you have any questions, do not hesitate to put them into the chat. I hope our event will not take longer than 2 hours. And if you need, please let me know. We will make a break. So let's start with small single thing. Small single thing. Please raise up your hand if you write Java.
If I write JavaScript.
As well. Why not? Okay, so we have at least a few people who write Java. Please, again, so slow down your hands and raise up your hand if you're running it in AWS. Because what we're going to talk about is AWS mostly. Alexander Kharkevich, what's your favorite cloud?
Especially for Friday, I really like I don't know, AWS.
Okay, I hope I pronounced your last name correctly. So yeah. Okay, so what we're going to do today is I want to show you different options how to run Java in AWS. And as ordinary, I'd like to, well, not as ordinary, and this time I'd like to start with a safe harbor. Everything what I'm going to show you today may be lie. If you think that if you'd like to base some technical decision based on my talk, please double check, because I might be mistaken. Don't forget to Google and check everything before applying. A few slides about myself. I'm Chief Software Engineer, have a couple of AWS certificates, live in London, and if you want, you can follow me on Twitter or on GitHub. Speaking about agenda, what we're going to do today, we will run our Java workloads on virtual machines, in Docker, in Kubernetes, in containers on cloud, and we'll finally use Lambda. This is our plan maximum. Realistically, we will see how much time it will take. Before moving forward, what I want to say that actually in AWS, we have many different compute options. What does it mean? It means that we can use many different options for running our workload, whether our workload is Java, JavaScript, or anything else. For example, one of the most famous service in AWS is EC2, which is Elastic Compute Cloud, which actually and literally is a virtual machine. And it provides us with many different options for many different use cases. For example, we have for example, workload which should be run constantly. We can that's why we can buy, for example, reserved instances. We know that our workload will be sporadic. That's why we, for example, in some cases, like to rent very cheap instance, and we can use some spot instance. So we know that we will use our virtual machines only for 15 minutes. We can use on-demand instance. We can even rent hardware in AWS. This is first option. Second option, which is again available for us, it is Kubernetes and container service. Kubernetes is actually the same as everywhere, but it is just managed by AWS. Container service is a bit different, but still quite interesting to use. So another option of running our workloads in cloud is containers. And the third one is serverless, when you need to provide additional, let's say, specifications for running your workloads, but you will pay only for what you use. as it is called, pay as you go. Let's start with the first part, with running AWS workloads using EC2 instances and Elastic Beanstalk. First of all, what's the use case? Why can't we, when should we use bare EC2 instances? Of course, if we have our own applications, which are already running on some virtual machines, what we can do is just perform a lift and shift migration. It's possible to upload our virtual machine in clouds, or at least our software, and start running it there. Another important use case is then you need some maximum throughput. For example, in case if you're doing some high performance computing, it would be nice to have a less overhead and do not think about containers, do not think about lambdas, and EC2 may be a good option here. Some time ago in AWS, it became possible to run your workloads on Apple devices. So in case if you're building something for Apple, you may use EC2 instances as well. And let's go to the most interesting part. Let's do some coding. Let's do some demo. So my first workload, which I'm going to run, is called dummy Spring Boot application. And my dummy Spring Boot application actually is not doing anything interesting. What's inside? Inside I have a Spring Boot and simple controller, which returns hello world. If you don't mind, I'm not even going to run it locally. It is definitely work. What I want to do is to run it in cloud. What should I do if I want to run this application in cloud? Well, actually, I need to have a virtual machine. And in order to get a virtual machine, what I need to do is to create it. I'm going to EC2 console, AB, demo, hello world. I'm putting the name of my virtual machine. I'm putting, for example, choosing my base image. I will use Amazon Linux without any additional customization. I will use a small instance type, which is illegal for free tier in order not to pay for it. I will use my key pair, which is already available, which I created in advance. And I have a couple of VPCs in my personal account. I will use default VPC. And I will use existing, let's say, existing security group. Why I need it, I will show it to you shortly, why I need this exact security group. Because this security group allows to have access on port 22 for SSH and on port 8080 for Spring application. And another thing I want to do is to find instance profile. This should be somewhere here. Let me do it as well. So I'm launching my instance. Let me shortly explain what I did. I just requested an EC2 instance in AWS in order to run my Java workload. Speaking about the first thing I did, as you may notice, I changed security group. This is my security group. I configured it in advance, and actually it allows me to access my virtual machine, which is on cloud. On port 22, it is SSH. On port 8080, it is for Spring Boot application. Simply stupid. Yes, this was the first bit. And second bit, let me connect to my virtual machine. I will do it from console. Because my key is on my computer, dev tools AWS. My key is here, SSH, EC2 user add. So voila, I'm in the cloud. So as you may see, I need 5 minutes in order to run my Java workload in cloud. But my application is still not there, and even Java is not there. And first thing I need to do is to install my Java. I prepared a small script for my benefit in order not to type a lot of in order not to type a lot. What I'm doing now, I'm just installing necessary packages to have Java on my virtual machine. But there is another big problem. How should I deliver my jar file into the cloud? And actually, there are a few options. Option with number one is to use something like an SFTP. And also there is another option. I can upload my bundle. I can upload my jar file into S3. I think it's much more interesting, so let's do it. In order to upload, in order to do it, and in order to not to do it right in front of you, I did it in advance. So I have a bucket with the given name, and there is a jar file inside. My next step is just actually copy this file from S3. AWS3, AWS S3 CP, S3 next name of the buckets. Bucket to 2022 hello world.jar up.jar. As you may see, it works. But why it works? It works because my virtual machine has an instance profile. Where is it? It should be, yes, IAM role. It has an instance profile, and this instance profile has a role, and this role allows my EC2 instance to read data from S3. So without it, my virtual machine will not have access to S3. So Amazon S3 read-only access allows me only to get data, but from any bucket. And next, Java -jar app.jar, and voila, my application is up and running. Let's check if it works. What should I do in order to check? Actually, is ordinary almost nothing. I'm copy pasting, for example, public DNS, HTTP, because no HTTPS configured. Hello world. Whew, it works, right? Right. Let me switch off at least my instance. I will need to have a few more instances during the demo. Do not want to waste capacity. Hope you do not have questions for now, because it is quite simple and basic stuff. And well, you may ask, why can't we use EC2 anywhere? EC2 almost bare virtual machines with and install our software on these bare virtual machines. Actually, there are many reasons, because as you may see, it's quite not complicated, but it is a bit tedious to create all this infrastructure on our own. I need to have security groups. I need to have my instance profile. I need to upload my software to S3 in order to install it. Well, in case if I'd like to, yes,
Can I have one question?
Yes, please.
Okay, just
Great.
see, since you are running very fast, so I was just trying to capture what you are doing. So just trying to summarize it. So you have created one EC2, and you run a jar into EC2, and you install Java probably to support that jar, to execution of the jar. So that's it, right?
Exactly.
Okay. So
Yeah.
so in the agenda, we are having some running a Java workload. So what do you mean by Java workload? Are we doing some kind of profiling or running Java application in different use cases like Docker, Kubernetes, and EC2, and probably Lambda, whatever other agenda you have shared?
Yes, exactly. So we have started, yes, this is what we're going to do today. We will run Java and different compute options in AWS. Saying Java, I mean Spring Boot applications, because they are simple.
Yeah, okay.
Okay, yeah, because what I want to show is just, let's say, not complicated, but maybe a bit more complicated than basic things. Next thing we will take a look into will be beanstalk. Of course, simple things with Docker and Kubernetes, with health checks and metrics, maybe Elastic Container Service and Lambdas. Yes, this is in the agenda.
Yeah, thanks.
Okay. Yeah, so speaking about EC2 instances. EC2 instances are good enough for many reasons, but as you may see, it's quite tedious to install, to deploy Java workloads there. And what's more complicated is that we need to perform releases, and performing releases without downtimes on bare EC2 instances also may be quite complicated. It will require a lot of, let's say, manual intervention and manual work. And there is a question. More likely, AWS already has something which allows us to do it, and even easier, right? And we have it. It is Elastic Beanstalk, which allows us to run application of different types. It allows us to run almost everything, whether it's Java, .NET, PHP, Python, or even Docker, and Go and Ruby. And in this case, Beanstalk will be responsible for deployment, for capacity provisioning, for monitoring, for everything. And what will be our responsibility is just to provide, let's say, bundles for our application, something runnable, let's say. Well, in this case, if we're using Beanstalk, it allows us to avoid dealing with underlying infrastructure directly. It will install updates for our operation systems. So it will install updates for Java. It will provide us with observability out of the box. So quite cool service. You can definitely find some documentation about it and dig into details. Today we will take a look into from high perspective, from high level, and in order to talk about it from high level, what we need to know. We need to know main concepts of beanstalks. Main concept of beanstalks are actually the following. We have application with application version. We have environments of two types. And actually, we have a platform which allows us to run everything. Let's start from the end. Let's talk about environment and environment types. In common, there are two environment types which are available. First environment type is web environment, which allows us to run almost everything. And saying everything, I mean that workload we're running will be available via HTTP. This is how it works. We have our application deployed to a set of EC2 instances, and Beanstalk will provide us with load balancer in front of our application, and will scale based on workload, will collect logs, will perform patching, and even help us with releases. And what else we have is worker environment, which is not available and accessible via HTTP, but it will be available. It will be possible to submit some work for this environment via SQS. So from our web application, we will receive some work and will perform some processing on the worker environment side. Simple? Simple enough, I suppose. In order to run application, we need to have a few files, which actually say what exactly should be run. It is build file if you'd like to build our application on cloud. It is prods file where we're explaining what should be started. And if you'd like to make some customization, we can use platform hooks. Let's write a very simple application, let's say, and let's run it in Beanstalk. Before doing that, let me briefly provide some details about web and worker environment. Web and worker environment are not really simple, to be honest. And for example, for web environment, what we have is HTTP proxy in front of our application, which actually receive request on port 80 or 443, and next forwards them to port 5000. It is needed, for example, for performance reasons. For example, on proxy side, we can cache some resources, for example, static files, in order not to make our real application responsible for it. And worker environment again works a little complicated. Because when we deploy in a worker environment, it automatically deploys an SQS daemon. And this SQS daemon listens to a particular queue, actually not listens, but polls a particular queue and next send request via HTTP to our worker machine or our worker application. Let's write a simple application which will demonstrate it. I already have an application, and let me show it to you. And by the way, do not forget to put your questions into the chat if you have any. I suppose you should have questions. So let me switch to another project. EV example. So let's run the application at least locally. So this is the application I have. My application is responsible for dealing with invoices. And as you may see here, I have web app and worker app. So what web app does? It actually does almost nothing as ordinary. It receives that it has a invoice controller, which is a simple web MVC controller. And let me run it locally. But before doing that, I need to start creating some infrastructure for my application. I need to create a SQS queue, which will be in the middle between my application, and I need to create a table in DynamDB. In order to do it, I will use a CloudFormation template. This is my CloudFormation template. In template, I'm declaring a queue, I'm declaring a DynamDB table, and I am declaring a few profiles, instance role and instance profile. This instance role and instance profile allows EC2 instances, which will be used to run my workload, to have access to DynamDB, and to have access to SQS, and also talk to, let's say, the underlying infrastructure agents. This is an instance profile for web environment. Instance profile and role for worker environment is actually very the same. It needs to be able to talk to worker tier, and it should have access to DynamDB. So in order not to create everything on my own, I will use this CloudFormation template to create everything in one go. So my template is ready. I need just upload it. It is over here. I started very quick because it was necessary to skip that boring part, which shows that in order to run application on cloud, we need to do many things. Let's see more interesting part. So right now, my let's say my tables, queues, and everything else is being created. And because I have AWS CLI configured on my local machine, I can run my application even from my local machine and be sure that everything is working. So let me do that. Let me run my web application. Oh, it complains that port 5000 is busy on my computer. Let's use another port, 5001, for example. 5001. This is my application. I'm creating invoices here, and you may see it as just a simple stupid UI. And at the same time, because my my application has access to AWS out of the box, it should write. It should already create records in DynamDB, and it should create records in. It should create records in SQS. So this is my records. in Dynamo, and these are my records in SQS. Let me, for example, see what is there. So these are my messages. There is almost nothing. So my application at least works. Let's run it in cloud. In order to run it in cloud, what I need to do? I need to prepare a bundle for my application. What does it mean, prepare a bundle? I need to create a zip archive, which will include not only, for example, which will include not only my application, but also some description, how exactly my application should be deployed. Let me start doing that, and while it is doing that, let's see into configuration which I want to do. So, what additional configuration I want to provide? For example, for my web application, what I want to do is to declare a health check URL, instance type I want to use, and instance profile, and name of environment. For my worker application, I also like to make similar configuration, and besides that, configure some cron activities. For example, when something is every minute every second, cron endpoint in my worker application should be accessed. Let's run this in cloud, and in order to do it, what I need to do is to first of all, go to CloudFormation and make sure that all necessary resources were created, and next I'm going to Beanstalk. In Beanstalk, I'm creating a new application, AB Beanstalk demo. Choosing the platform I want to use Java, and here actually there are many options I can use. First of all, platform branch, which literally means which Java version I want to use. And if we take a look here, we will see actually, besides from Java, I have a Tomcat. What's the difference? In case if I choose Tomcat, it will allow me to upload var files. In case if I'm choosing Java, it allows me to what to do. It allows me to upload any jar file and run it. So let me start and upload my first my bundle. It will take a few minutes to run it. Sorry, not to run, but to upload it. And while it is happening, I have time to take a look into Teams. By the way, I don't see your questions.
Yeah, so
are you still here with me?
Explicitly, in this instance, you can't just upload in S3 directly and it will pull it, your bundle, like previously you did.
Exactly. Yes, I can upload it to S3 and can use it can take bundle from S3. That's true. So what I'm doing.
The concern here is that that bucket needs to be public. Cannot be your private bucket, I think. So that could be a problem for uploading your binary or source code to publicly available endpoints.
Yeah.
So that's something to keep in mind.
Yeah, thank you very much for joining. So thank you very much, Nikita, for joining. So what I'm doing, and thank you very much for your assistance. I think if I have issues, I can ask you or Alexander for help. So what I'm doing next, instance roles, service roles are here. So I create a custom configuration. I chose an instance type of a bit bigger size, just to be sure I have enough. Just to be sure I have enough resources. And next, what I changed, I chosen proper security group and not security group. I chosen proper service role which has access to everything to run my application. I chosen different instance profile. Let me check what I chosen. The proper profile. Yes. Let's take instance bulk, I chosen proper profile, which have access, this one, which has access to SQS and DynamoDB. And to be honest, I'm ready to run my application. So something is happening. Yes, exactly, Nikita. I'm not doing everything manually. I'm doing it partially manually. That's a good point. I create some things manually. I create some things automatically. And yes, you're absolutely right. We have AWS CLI. We have AWS Cloud Development CDK, Cloud Development Kit, and we have CloudFormation. So I'm doing partially one, partially another. But yes, you're right. We can do everything from code as well. So what's happening? Let's do CDK workshop next. Yes, let's do it. And I think it would be nice person with a solid cloud background to do it as well. So let's take a look what's happening here. This is my personal instance. It was here before. This is instance which was created for us by Beanstalk. I hope it should become available almost immediately. Not available yet. Maybe application is not running. Let's check. At least we have access on port 80 and HTTP 80. Application is not ready yet. Application is not ready yet. Let's take a look into Beanstalk. What's happening? So Beanstalk says that application is still installing. It will take a couple of, maybe not minutes, but a few seconds to do it. So, colleagues, I see there are a lot of people here. What do you ordinarily use for running? Do you use containers or EC2 instance as well? From people who raised hands. Konstantin, what do you ordinarily use? Konstantin Baranov.
Docker.
Docker. Okay. Docker is also quite useful. Oh, warning? Why?
And Kubernetes, running everything.
Okay. This is, oh, something is not good today. Unexpectedly well, maybe unexpectedly, maybe expectedly something. Maybe expectedly something went wrong. So this is my application environments. Let's take a look into logs. When I checked it before the session, everything was relatively good. But as you know, when you start the session, something went as ordinary, something is going wrong. So it's happened now. Let's take a look into logs. Nothing interesting here, and I think this one will be much more interesting log. Right. Oh, what's up? By the way, nothing really interesting which says that something should go wrong.
Can you open this web log, that last file?
Huh?
Web out log file. Yeah.
This one.
Yeah, this
Okay.
could be. Yeah.
So my application started. Okay, so my application has been successfully started and port is correct. Huh?
Nothing went wrong. I think you should refresh and it will.
Yeah, I think so. I think I just need to refresh and it will work. Yeah, it works. Hooray. So it works. And what's happening now? Yeah, it is not working because by the way, why? No, everything is working. So I can create, but my invoices are not being processed. In order to process my invoices, what should I do? I should create another, let's say, environment inside my application and install, and it will be worker environment. Let's do it. Why not? Creating a new environment of type worker environment, AB demo worker. Nothing special here. ID worker environment. Again, it is going to be Java, Coretta 11. I'm uploading my code. I can upload it to Bucket, but I can upload it from here. Let's do it. List. To configure more options next. In order to make my environment a bit bigger, because I noticed that I can run my workload in T2 Micro directly, but I cannot run my workload on T2 Micro when I'm using Beanstalk. Looks like Beanstalk agent requires a lot of resources, but maybe not a lot of resources, but requires some resources anyway. So let's move forward. So let's choose capacity instance of a bit bigger size and provide proper everything. But another thing I need to mention here is that actually I have a queue. This is the queue my worker environment will listen to. And next post them to somewhere. And in order to be aware where exactly this is this somewhere, it is in the root context. So I created a controller which receives post payloads and processes it. So let's create an environment and see how it will work all together. So second environment, pending. And let's take a look into my environments and my instances. Nothing really special. It should be there should be third running instance. Pending, sorry, it takes some time to create it. And while it is happening, I see Andrei Frutov put quite interesting case, Docker and Docker. Can you please elaborate? Why is it necessary to use Docker and Docker? Or tell us a little about your use case.
Use case is when you're running some workload inside of the Kubernetes and Docker, and you need to start a Docker container. So it was connected with Jenkins. When Jenkins running inside of the Kubernetes and it's starting the container to build application clearly inside a container, then kill the container.
Okay. So thank you very much. So looks like it's taking some time. I do not think we have to wait so long until everything is happening. We can get, yeah, but we still can do it because my instance is almost ready. What I want to say is that we can get back to it a bit later. Let's say in 5 minutes, and see how it works. Or maybe we can take a look into it right now, because looks like, again, everything seems to be working. So what should happen next? Can you look? What should happen next? Oh, as you may see, my records have been successfully captured by my SQS event has been successfully captured by worker environment, and worker has successfully updated the status. If I create a new record, this one, in a second, again, it is captured. So what I wanted to show here is that actually, as you may see, we can build even big, and we can run even big and complicated applications in cloud with minimal effort. As you may see, I did almost nothing in order to run a couple of applications and distribute workload across between them. One application is doing some, let's say, doing some even not stupid but quite simple, providing some simple web interface. Another application is actually responsible for processing requests from it. Speaking about AWS well-architected framework, it's let's say it's a good way of distributing workload. So, gentlemen, I think please raise up your, please put thumbs up if you're still here with me. Okay, yeah, I see hands, and I see a couple of raised hands. Colleagues, do you have questions? Or you're just showing that everything seems to be okay? I hope everything seems to be okay. And let me terminate my environments, and we will move forward and start building Docker images and Docker contain and running applications in Docker. If you don't mind, we will do it locally, and we will run our containers and Kubernetes locally as well. So I'm switching off my environments because I'm using VMs which are out of free tier. Moving forward, what I'm going to run in containers. In containers, I'm going to run simplistic workload. And before moving forward, this was the application we deployed right now. So what we had worker environment, which is responsible for receiving events, saving it to DynamoDB, and next sending a message to SQS. And next, our worker environment captured this event from SQS, processed, and update record in DynamoDB. Not bad, not good, just an example. Quite interesting. Let's move forward. Why can you use containers and when they work better? Of course, in the case if you have a hybrid environment or you already had containers in your previous, let's say, life in your local project or on-premise, you can just lift and shift. Another important and quite useful use case when you have batch processing. Here you can use containers as well. And considering, let's say, it's possible to say that you're paying as you go. You're always have option to pay as you go in AWS, but maybe it is not always work. Because if you have application which have to receive HTTP request in containers in cloud, and in this container, you still have to have some containers up and running. But in case your workload is extremely high, you again can go and run more containers. This is the application I'm going to run this time. simple examinator application, 2 workers, which provide some questions for exam, and 1 aggregator application, which needs to, which will be used to receive the questions from both of applications and return them back to the front end. Simple application. Let's write it. Let's run it. So first of all, I will start and run this small application locally. Oh, I see. Good point. It's not a point of presentation, but you could replace SQS with DynamoDB stream. Yes, of course, I can replace SQS with DynamoDB stream, because why not? Because I can do it. So this is my application, and as previously, there is nothing special which might be interesting for Java developers. It is just a simple Spring application which has a couple of REST endpoints, and these REST endpoints are just proxying requests to subsequent services. My first thing which I want to do is to just run this application using Docker. And in order to do it using Docker, what I need to do? Simple thing, because first of all, I need to build my Docker containers. And in order to do it, I will use Amazon Kata provided by AWS. And second thing which I need to do, which I really want to do, is to make sure that my applications are started in proper order, right? Because it would be nice my providers, like service provider for math and for history, to be started first, and only after that my exam aggregator application starts. So in order to do it with Docker, what I can use? I can use health checks, by the way, because it is a feature. This is a feature which is available out of the box, and I can say that my aggregator application will start only in case if provider math is healthy and provider history is healthy. But what should say that my providers are healthy? It should be health checks. And if we're speaking about Java and Spring, what we have is Actuator. It is a feature which is available out of the box. And what's interesting there? We actually can, let's run this application and let's see. We actually can, if you're running Java in cloud, if you're dealing with Actuator, you may already know it. But if not, I hope it may be interesting for you as well. So if you go to a special endpoint, which is Actuator health, we can get an information about health of our application. It says that, for example, our application is up and running, and our application has many dependencies. For example, it depends on disk space, it depends on some custom, let's say, metric, and in case if something went wrong, our application is not healthy. For example, not enough disk space, or we do not have enough, let's say we don't have capacity, or we have no connection to some third party. And it would be nice to check and contribute to this metric, to this health indicator. And in order to do it, what we need to do, or what we may need to do, is to write our own health indicator. It's simple. What we need to do is just to write to create a new component and implement health indicator interface. And here, by doing relatively simple thing, for example, I'm switching phase of the moon in my application, I may be sure that my application is not healthy now, because phase of the moon is not correct. So my application is down because my custom metric says it should be down because phase of the moon is invalid. This health indicator allows me to do it. For example, you have many third parties, and in case you need to be sure that your third party started first, you can use it. Quite useful health indicator. Why it's important? Because it allows us to contribute to health checks in Docker or in Kubernetes, right? For example, in case if my application is healthy, only after that I can start another application. That's tricky case in Docker because, well, what we have depends on, but depends on allows us to start containers in proper order, but it doesn't allow us to check that application is ready to receive requests. In order to solve it, we can use conditions, we can use health checks too. So let's run it and let's see how it works. So where am I? I'm almost there where I need to be. I already have all my containers up and all my images built. Let me just do this thing. I will add Docker stats. It will be here, and here I will start my application. As you may see, first which starts are my providers, and my application waits until third application will wait until my provider is up and running. Okay, it even doesn't work because it says portal is already in use because it looks like I did not switch off this. Let's restart in order not to wait and start it again. So first, in this case, as you may see, first started my providers, and only after that, when providers are healthy, my aggregator application started. Simple way of doing that. Simple way of doing it. Hope if you use Docker, you already know all of it, right? Please thumbs up if you're still here with me. Are you still here with me, by the way? I see a funny face from Nikita. Nikita, what do you want to say?
I'm just giving you a different smiley. That's it.
Good. Thank you very much. Okay, so moving forward, my application are simply stupid, and if you have questions, do not forget to put them into the chat or do not hesitate to unmute yourself. And my next step is to run all these applications in Kubernetes. I already have one node Kubernetes provided by Docker Desktop locally, and in order to do it, I need to write a bit more configuration, right? Because if you're running Kubernetes, you need to have a separate specification for your deployment. This is my spec for deployment. And what's interesting here, Kubernetes is a bit more flexible and a bit smarter than Docker, so that it's possible to have two probes, not only a probe when my application is up and running, but also when to check whether my application is ready to receive requests. And that's why we can separate liveness and readiness probes here. We're separating it by adding this simple parameter. So as you may see in my deployment YAML file, which is the first, I have three. I have three deployment manifests for deploying my applications. Let me run it in Kubernetes. Why not? Because in the talk it was said that we will use Docker and Kubernetes, so let's use it. In order not to set namespace every time, I have created a separate namespace training demo for my, let's say, for my examples. I will switch to it. It's long command. And next I will deploy it. kubectl apply -f 01. And as you may see, the Kubernetes already started creating deployments for me. Oh, a lot of. So my pods are almost there, but unfortunately my application is not working. Let me show why is it not working. For example, in case if I'm sending a request to build my exams, where are my requests? It says that actually unable to connect port 8080. Why? Because my application is started, but I have not created services. And in order to make my application public, I need to create a service of type load balancer. So let's do it. Apply -f O2. So moving forward, trying again. Yeah, again, as you may see, it works, but 500. So aggregator works, but my providers are not working, or at least are not visible for my aggregator. Why? Because in order to run it on Kubernetes and to make my services public, I need to create services for them as well. Let's do it. Apply -f O3 and voila. I have everything I need, and my application should start working. My application should start working. Well, there is an interesting day. Everything that should have been working from the very beginning is not working. Let's try to understand why it's not working. I will use lens to see what's in my containers. It's interesting, you know, because I checked all my examples before the session and everything was fine. But as ordinary, when you're making a demo in front of the customer, it is not working. Please put thumbs up if you faced situation like this, when everything works on my machine, but doesn't work when you need it. So this is lens. Let's check. Maybe it started to work. Yes, as you may see, while I was talking to you, it started to work. It started to work. So you see, everything is working. My application is working. All three components are available. What I needed to do is to have a fancy discussion. Okay, but anyway, let's see what we can do from Lens. Lens is quite useful, and if you use Kubernetes, you know that even without me, it allows me to see what's happening inside. It allows me to see attached to a particular pod. It allows me to view at least logs. As you may see from my logs, I have seen what I seen that, well, for aggregator application, math provider has not been available for some time. But now everything is working. Okay, so I think we're almost done with this bit. Let's move forward and let's run this application in cloud in Elastic Container Service on ECS. Why I'm not going to run it in EKS? Because, you know, EKS will be actually the same. Because Kubernetes, it is Kubernetes, it is everywhere. It is similar everywhere, but the ECR is something which we're not using every day, so let's try using it. If we're talking about ECR, in ECR we have three launch types. First, the simplest one is EC2 launch type, which says that our workloads will be started on EC2 instances. So ECR will create EC2 instances for us, deploy Docker agents there. Sorry, not Docker, ECR agents there, and we'll deploy our containers into EC2 instances. The main benefit is that it is simple. Main drawback is that if you purchased a big instance, you may underutilize it. Another option is to use serverless when you're paying for what you're using. It is Fargate, and in this case, you will run your tasks and pay only for time when your tasks are running. And also, by the way, there is a third option, which is external launch type, which allows you to run ECS agents on your infrastructure. And from this infrastructure, ECS will be used for running tasks on your own infrastructure. Quite interesting. Let's run. And in order to run application, I'd like to show a case a bit different service as well. So you may have already noticed that I have my code, and code is already on GitHub. So why can't I use, for example, forget name of the service, code build for building my application and publishing my Docker images to ECR. And let's implement it. And what else I need to run my application in ECS is VPC. Inside VPC, it will be cluster. And within it, I will have tasks. This is what I want to use. Let's try to build it. Let's try to build this monster. So there will be a lot of interesting things, I hope. So what I want to start with is, again, with deleting my old stack and with CloudFormation. I will create a lot of resources. All of them are here. And first, what I'm starting with Elastic Container registries. So Elastic Container registry repositories, because I need to have a place where I will push my Docker in images. Thank you very much, Konstantin. I also believe that everything will work from the first time in this example. Because, you know, I checked. So let's start with ECR. ECR, ACS, ECR. Let's start with ECR. I will not do anything. So registries are going to be created. So we are here. My registries are here. So 3 registries. Next step is to create Next step is to create a quite useful component, which is project for cloud build, for code build. I'm sorry, ECS code build. Creating everything. Stack is going to be created. And while it is created, let me show what will be used for building my application in cloud. Actually, simple. It will be a build spec file. You know, if you're dealing with Jenkins, you need to put Jenkins file. If you're dealing with cloud build, you need to put is this code build. You need to put code build here, and here I'm describing what exactly I'm going to do. And my build script is relatively simple, but maybe not clear from the very first time. What I'm doing here, because as I showed for my Docker images, I'm using custom repository for downloading kata. First thing I need to do is to log into this ECR registry in order to have access to kata. Next, what I'm doing is I'm building images, and as soon as everything is okay, I'm logging into my private repositories in my private ECR and pushing images there. So hope this step is done. This is configuration. This is a relatively big configuration for code build, and it should be almost here. It takes time to create it. But anyway, at the end of the day, yes, This is my project, and everything is configured in one go out of the box. Almost as Nikita said, everything should work out of the box, and you should not create so many things manually. This is what I did. I created a lot of things automatically. So let's start and build my project. What should be the outcome of this process is images published to ECR. So build is happening. Code is on GitHub. Build is happening. Come on, build, please happen. Okay, it is happening right now. While it is happening, let me get back to CloudFormation and start creating other bits which might be required for me. So what I'm going to start is, what I'm going to continue is to create a VPC for my examples. I'm creating it here separately because just for convenience, because in this case, I will see what went wrong during creation. We have here a very high qualified cloud engineer, Nikita. May I ask you, may I put you under the spotlight again and ask quite tricky question? So what is the industry recommendation to create, for example, a complex infrastructure? What is the mainstream today? Because as you may see, I'm creating, let's say, many resources, but bit by bit, in order to track this is created successfully, this is fine. But what is the industry standard now?
I mean, there is nothing such thing as an industry standard, really. Someone who's struggled with this thing for the last few years on a daily basis, I can tell you this. If you can use cloud native tools, you should use them. Not chase being cloud agnostic, because that's not really possible. I can, like for AWS, I cannot recommend CDK enough. They have the most amazing documentation from all other tools. They also do a lot of abstracting for you. Like, for example, when you create an ECS task, right, a Fargate task, security groups, roles, and all the permissions and all the reasonable defaults for your application will be created out of the box with zero configuration. You can customize if you need to, but there is a lot of stuff they abstract away. So it's really good. Other than that, if you want something that's very close to standard, then it's Terraform, unfortunately. I mean, I can probably waste, I don't know, 3 or 4 days of your time talking about differences between them. But yeah, like Terraform is the most common tool and it has the widest adoption, I would say. But if you are AWS and if you're trying to use as much managed services as possible, then CDK is great. CDK is amazing.
Thank you very much. So while Nikita was talking, thank you very much, Nikita. It's a very good addition, by the way. That's very good addition. What has happened? So VPC has been successfully created. My project has been successfully built, and as you may see, it has even been successfully published to ECR. So all my projects are here. So what I'm doing next, I'm creating a ECS cluster. So my cluster is again here, and my next step is to start creating my example cluster is name of my cluster. I need to create a service, and I can create a service locally. I can create a service manually, but at the same time, I need to create tasks first, and next create services. So, and also there is one tricky thing. So these are my tasks. These are my tasks, and description is relatively big, but this is the main bit. This is the main bit. This bit says that I will name my task aggregator container, and it will be in my task, I have my containers, and this is definition of my container. So in one task, I can have multiple containers, for example, for cases when I want to use sidecar with Istio or anything else, so that I can have many container definitions here. But what I'm doing here is I'm just declaring my definition for my task, and for this container, I'm limiting CPU, memory, performance, post mapping, and saying that here is the place where I write my logs. And for the whole task, I'm also making some restrictions. I'm restricting it with memory and CPU, providing networking and execution and task roles, and saying that I will use Linux for running my application. So this is it all in my task definitions. Let's create these tasks. Many things. AB is yes, tasks. So tasks family for my tasks, and allow creation of roles. Task is being created, is going to be created. So, but tasks will not run my application because tasks are just definitions. Let's say they are purely something like a Docker compose, but they are not creating instances. In order to create instances, I need to create services. And services here are actually, again, a piece of definition. And what I'm going to create, I will not create 3 tasks, I will create only 2 tasks because I'm using free tier, and within free tier only 2 services are allowed to be used at once. This is the limitation. But what I'm doing here, I'm creating a service, so resource of type service. This is name. This is where I'm going to put my service. This is what this is the number of instances I want to use. I will use Fargate for running my services, and security groups in order to provide it with access, in order to provide my services with access to each other and with access to the outer world, and subnets where my task should be put. This is the first simple bit, but also there is a second quite interesting bit which says that actually my aggregator, which is entry point, should be connected with a particular target group in my load balancer in order to make this task available from the outer world. And this is the task definition I'm going to use. Second service is the same. And as you remember, my services are talking to each other. For example, aggregator talks to provider service, to this one. And in order to do it, I need to create oh my God, what I need to create? I need to create private DNS namespace in service discovery. This is where I'm creating my DNS. And here I'm creating a registration of a particular service in my DNS. So if in Kubernetes we created services and all this routing was performed under the hood, here we need to create private DNS. We may create a private DNS namespace and create a registration of our service in that DNS namespace. Let's see what we have now. And right now we should have tasks. These are my 2 tasks. Come on, please show me them. Task definition. So I have task definitions for everything. I have my cluster, and next step is to actually create services and perform registration of my services everywhere. PECS services. So many, yeah, I see the great comment that DNS is optional, and yes, you're right, DNS is optional. I can use ALB as well, but I do not want, in my particular case, I do not want to use my provider's public, and I do not want to create additional, load balancers, because just because for simplicity, first of all, and because in my current situation, I'd like to replicate behavior I had before in Docker, where I have entry point, and when I have a service which is receiving requests and next send it to providers. But anyway, thank you very much for providing an option. Alexander, that's great. Thank you. So we're almost there. If we take a look into our cluster, we will see that in cluster, what I have services, and services are, let's say, containers for my holders for my containers inside services. For every service, I have a task. Task is actually workload itself, and my workload is going to be started. They are almost here. So this is my task. Let me check that I can access it. Let me do a very simple thing. Let me access it via public IP address. It also will be available. It also should be available via. It also should be available via load balancer, but let's say for simplicity, let's not do it for now. So. Okay. Okay, let's go to ELB. Looks like it still takes time to register my workload in ELB. Load balancers. Load balancer. This is my load balancer. Let's see that everything is there. Ingress load balancer. Inside my load balancer, I have a listener, and there should be something connected with it, target groups, right. ECS target group, port 80, and just to check that my target has been successfully registered. Yes, my target has been successfully registered. It is healthy. Let's finally send a request to my application. Because as you may see, something went wrong with direct stop and run. Check. Okay, it is a bit slow today, but as you may see, I suppose it should work. It just takes time today. Colleagues, how are you doing? Are you still here with me, or you fell asleep? Are you following what I'm doing? Because what we did, we just started application a few containers in ECS. It was not as simple as running containers in Docker or in big enterprise. Oh my God, I'm blind. Or yeah, as you may see, at least it works. Which provider? Math. Because I'm blind. I added HTTP listener on port 80, but I could try to access port 8080. So as you may see, everything is working. My underlying application is working. It resolves, aggregator successfully resolves a request to data provider, and voila. As it is possible to say, 20 simple steps to run 3 containers in cloud. Hope you're still here with me, and hope you're still enjoying the session. Okay, maybe you have some questions.
Yeah, I just have some comment. So,
Yes.
Alexander, you mentioned that when you specify test definition, specify the CPU limit, etc. I just want to highlight, if you're using EC2 under the hood, not Fargate, this is not like limit, it's like minimum value, but it's not high limit. So if you have EC2 and it has free CPU, it can take all CPU. And for example, in ECS, in CloudWatch metrics, you can see that your task can consume like 1,000 CPU items. So it's like, if it's not reserved by another task, you can use all CPU of your task. So sometimes it's very useful.
Thank you very much. That's a very great addition. Thank you very much. And I would rather say thank you very much for still being here with me and for listening to me. I see you're still focused on what I'm showing, because that's very great that you're noticing so small caveats. Thank you very much. Okay, so let's move forward. We have 40 minutes for the last one bit, and before going forward, if you don't mind, I will at least switch off my services, because my services are money consumers here. They will, while they're running in Fargate, I'm paying for them. I don't want to pay a lot, but if you, let's say, I have no objections against spending a few, let's say, pounds for demos. Well, let's move forward. Last one bit is AWS Lambda, and we will run Java workloads and Lambdas as well. We can run Lambda and write Lambda on our own, right? Right. We can go to AWS console, create Lambda, and it will work. But in AWS, there is a better way of doing it, which is serverless application model. Well, and by the way, I'm saying it's a better way of doing it. I'm not saying that your Lambda will be better if you're using SAM. It is just easy to deploy it when you're using SAM. This is what I want to say, because SAM is, on the one hand, it is an extension for the CloudFormation, and on another hand, it is a set of command line tools, it is CLI, which allows you to simplify some actions. For example, it allows you to run your Lambda locally if you want. It allows you to deploy your Lambda to cloud in one go, and it allows you to, well, what else? Actually, this one. It just helps. So let's take a look into the application I'm going to build, because it is a bit more complicated than previous applications I show. This is, let's say, my this example based on one of my previous projects. It will use a public API which is called service which is called ERLX, and ERLX is a service which publishes changes in legislation of European Union. There is one API which is called Alerts API. This Alerts API allows to get a list of documents which were updated on a particular date. So we will have one service, one Lambda, which will do that. Next, I need to filter out documents which I have already loaded and load using another API meta information about my documents. So in common, what I'm going to have is to have 3 Lambdas. I will use DynamDB for storing information about already loaded documents. Documents themselves I will store in S3, and for kicking it off, we'll use API gateway, and we'll use the step function for orchestration. Quite big stuff, quite big. So we have already seen S3 today. We have already seen, at least on a high level, DynamDB step function. Step function is a really interesting thing, which is a state machine for AWS, which allows us to run some orchestrated workflows. For example, like in my case, it's necessary to get a list of documents using one API, next filter out some other document, and next documents which are outstanding to be downloaded. This is the workflow I'm going to implement, and let's run it. Let's run it. Lambdas will be written in Java as ordinary, because, as I said, we run in Java, but I think I will not write code itself today. I will just show examples I already prepared. So 35 minutes left. I suppose that's enough for running it. some Java example. So what is the starting point for deploying all that stuff? Starting point for me will be to create a template. This is my, let's say, extended CloudFormation template. And in this extended CloudFormation template, what I have is, as previously, set of parameters. For example, here I want to know bucket name, which I will use for storing my documents, and DynamoDB table, which I will use for storing identifiers of loaded documents. A few other things. So speaking about other things, my other things are just 3 Lambda functions. This is first Lambda function, this is second Lambda function, and this is third Lambda function. My Lambda functions here are just Java code. I will show it to you shortly. And while we're talking, I need to start building my Java applications because it will take time, unfortunately. I've got some examples. In order to start doing it, what I may use is I may use SAM. SAM is CLI, SAM builds use containers, and SAM what? SAM build. Come on. Okay, it's running, it is building. So what I have here in my template file is my extended CloudFormation template is actually first bit, which says where exactly my code lives, and second bit is what is the entry point in my code. For example, my first function is called alerter. It goes to first API and retrieves list of documents updated on a particular date. Second lambda is filter, and third lambda is downloader. And also what I need to say is that I will use Java 11, and I need to provide my lambda with access to something. For example, I need to allow this lambda to write data and read data from DynamoDB, and I also need to allow it to write to S3 bucket. And of course, I do not want to hard code anything in my code. That's why I'm providing some environment variable for my code. And of course, my lambda function one depends on another. So as you may see, it has been successfully built. And let's take a look into the code itself. Well, it is simple Maven project without Spring this time, But what's interesting here? Actually, there is nothing interesting here. This is my handler. It should implement request handler interface. And within this request handler interface, what is available? Oops, not. Sorry. Let me double check that I'm still. Yes, it is request handler from Amazon. Yes, and my request handler is simple. It receives a request and produces a particular response. So everything which is happening under the hood is happening under the hood. From my request, what I can do is that I can read, for example, some parameters. This is my input, and from this request, I can, for example, get, let's say, parameter from URL. And that's actually all. Let's run it. Because the rest of my Lambda functions are, again, relatively simple. Here I have just a simple handler, which implements, again, this interface and handle my request with context. So reading data from command line. Sorry, not from command line. I'm reading some data from, let's say, my request, and based on it, building queries for DynamoDB. What I have at the end of the day? At the end of the day, when I executed SAM build, I got a folder which is called AWS SAM, and inside this AWS SAM folder, I have a template.yaml with where some values are replaced. because if we take a look into my initial YAML, we will see that it is relatively small. It declares just lambda document DB table, and that's all. And it has a simplified declaration of policies. But what I have here in a real template, it is it was, let's say, transformed, and right now runs of functions are still not here, but nevertheless there are some placeholders for doing it, for putting it here. One single thing which I haven't shown yet is state machine definition. We'll get back to it shortly. So what else was built here? My code is built here. It is here, and set of dependencies. It is also here. Let's deploy the code. In order to do it, what I need to do is sam deploy. What's happening is my jar files are being uploaded. And let's go to AWS back. So I'm going to Lambda. And what I have here with my lambdas, I have application. I don't have applications now, but as soon as all jar files are uploaded, it will be created. And again, you know, Sam is working on top of, as everything else it works on top of CloudFormation. So if we get back here to CloudFormation, we will see that actually what's happening, it will start creating resources via it. Oh, file to create it. Oh my God, the bucket already exists, and oh, my table and bucket already exist. Okay, it is rolling back. So let me delete my bucket and table. In order to show everything end to end. You know, it's ordinary. Everything was working during preparation, but not working now. So no tables, seems to be fine. Okay. Так, failed to create, alert rolled back because bucket already exists. Right. So there should not be bucket with a given name. Bucket with given name is I emptied it, but I have not deleted the bucket itself. So voila, nothing. Let's deploy it. This is the region. Oh, I completely forget that actually I can overwrite A/B test underscore test 2022. Confirm. Yes. 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 Go and create finally. So it is not uploading. It is what?
You have to delete CloudFormation stack, I believe.
Yes, I think so.
I mean, if it's in rollback complete, then it should be fine. You can just push the change set. Well, I mean, manually through CMI.
Yeah, so the problem is that the stack can exist in a different region.
Use CDK, look, use CDK, does all this for you. It will also clean up your buckets for you when you delete them. You don't have to worry about resource names because it will auto-generate them for you. And
yes.
it does change sets automatically. Sorry, I had to say it.
That's very good addition. That's very good addition. Thank you for saying that. Okay,
If you are
so
deploying to AWS in 2022, you should not use CloudFormation. AWS even says so themselves.
next time. And anyway, I have 25 minutes to accomplish with deployment. I hope everything will be okay. Well, yeah, I see what's wrong. Okay, yeah, finally it is ready. I suppose my local region is different. That's why when I'm deploying it from console, it deploys to a different region. That's why I haven't seen this stack before. Okay, so what's happening? So as you may see, resources are being created, DynamoDB table created, S3 bucket created, lambdas are going to be created right now. So let's get back to the console. Let's take a look into lambdas. And as you may see, this is my application. Creation is in progress, and within my application, it demonstrates that there are a lot of resources associated with it. Actually, this is, let's say, a main benefit of using SAM, because it allows you to see everything in one place. So almost created.
I would argue that serverless framework is better than SAM. If you're not want to use CDK, then serverless framework is probably a much better option.
Yes, will not argue. I think you know better. Thank you very much for clarification. Yeah, but well, for simple tasks, SAM is good enough. Okay, so where am I with my deployments? Thank you very much for filling time. Okay, so my deployment is happening. Something is going to be created. Oh yeah, so the longest as ordinary it takes to create, longest time it takes to create state machine, and it takes to create API gateway. Let's take a look into the state machine while we're waiting everything to be created. So state machine. To be honest, I was really confused when it was necessary to declare a state machine in JSON. I thought YAML is the worst language for specifying something which is not declarative, but next I noticed that JSON is a bit is not good as well. But still, this is my state machine definition, which actually says that I have many steps, and for a particular task type, I need to invoke a particular something. I need to do a particular invocation, and here I'm providing a name of function I want to call from my state machine. And as you may see, what is maybe not a benefit, but quite interesting, is that I may not use. I need to somehow connect my state machine with my Lambda functions, and in order to do it, I need to provide. This is my state machine definition. I need to provide substitutions. Here in my state machine, I'm saying that in every place where I'm using, for example, ingest alert filter ARN, I need to replace it with ARN of a particular Lambda function. And this is actually it. Not long, but let's say not long or complicated, but let's say still you still need to be aware of it. Let me say that. So my stack has been successfully applied. Let's take a look into the step functions. Step functions. Come on, this is the state machine I have. This is my state machine. There is no executions yet, and this is how it looks. So what's left for me is to run the application, right? In order you to be sure that everything is working. As I said, my application is exposing some public API. This is what is exposed. So my first Lambda is automatically registered in API gateway. And what I can do? Well, let's start it. Let's start the application. And as far as I remember, the easiest way to do it is to send a post request, is to use Postman. It is good enough for that. Or I can use even this, but unfortunately, right now I don't remember exact parameters I need to provide. So, look, sorry, yes, this one. This is something I need to provide. Oh, sorry, not headers, of course, request by. So I'm sending this request. It kicks off the execution. So as you may see, this is execution. It has been successfully started. And if I get back to my state machine, in state machine, again, this is the execution of my state machine. My first Lambda should return around 100 of items. And here, right after that, my rest of my Lambdas start execution. So it works. As you may see, I haven't faced any issues running Lambdas in cloud. Beanstalk was not so, example with Beanstalk was not so successful, but still everything is working. So I think that's it. If you have questions, do not forget to ask them. If not, let's wrap up. So, as you have already seen, AWS has many compute options. Choose wisely whatever you want and whatever you use. Because, maybe it's much easier to run something in bare virtual machine. Maybe it's much easier to run something in bare in simple Lambda function. And it's as ordinary, let's say, for special case, there is a special tool, especially when you're talking about cloud providers, because more likely if you have a quite complicated issue, there is a quite interesting tool which allows you to write a long YAML in order to configure it, in order to solve your task. Because as you have already seen, in order to run a serverless application, it took maybe 5 minutes, but previously I spent a huge amount of time writing this big YAML file. Observability, we haven't talked about it a lot, but nevertheless, it's worth mentioning that observability is something which allows you to sleep good at night. And as Nikita mentioned, thank you very much for comments. No tools which you use. Maybe there is a better way of doing something. All examples I've shown are available on my GitHub. Thank you very much for spending this almost 2 hours with me. Hope you enjoyed the session. Thank you.
You missed one important bullet point.
Yes, please.
Thanks to you, Alexander. Thank you very much.
Security, Alexander, security. Always security. Always be careful of what you deploy, where and why.
Thank you. That's a very good point. I suppose, well, security is complicated topic. We need 2 more hours to talk about security, I suppose, right? Because, well, there are so many caveats how to do it properly, and it's quite hard to always keep track of that recommended least privileged access policy and that least privileged access rule. And yes, you're absolutely right. And what I've shown is that simple things to show different compute options. But you may notice that I used quite wide, let's say, permissions and allowed, for example, my EC2 instance access all S3 buckets instead of limiting it to one single bucket. That's true. And again, I suppose it requires a separate session in order to talk about it. But thank you very much, Nikita. Yes, there is quite a good comment from Alexander regarding running lambdas using Gradle. Well, there is a separate. It's a separate discussion about how to build a Gradle VM image properly, because if your lambda is simple, just let's say convert one JSON to another, maybe you do not need Java at all. But if your lambda is complicated, maybe it might be tricky to build a proper Gradle VM image, because, well, first of all, it takes time. Second, if you're using some complicated frameworks like, I don't know, Kubernetes or even some features from Spring, you need to provide your Gradle VM compiler with many hints in order to make it working properly. But yes, using lambdas with Gradle is a good option.
Spring and Lambda sounds strange.
Why not? Why not? Because Spring has support
Too
for
expensive
box.
for the
Too
memory.
slow. Too slow.
And
Very
slow.
slow.
Yeah, even
painfully
if
slow.
Alexander, if you open your sample of Java code, I will highlight the main problems. So, for example, you're creating DynamoDB client every time. It is like
Yes,
the
exactly.
biggest, and you should move as much as possible to static. Everything it will all free because you pay for only execution time, but it is like startup time. So even this code can be improved, I believe, 3 times like startup time.
You shouldn't initialize clients in your handler. That should be done elsewhere, because it's also going to be cached between executions. While your runtime is hard, it will be cached. That's significant performance improvements from that. But yeah, I mean, that again, that's not the point of the session. We could probably do another one, like 2 more on how to write lambdas properly. That's
exactly. Sure. Exactly. It will take another couple of hours in order to show it, because it was like a good overview of what you can use. And next, what we can have is separate topics, separate session for separate topics. It will take no less than 2 hours to talk about every of them.
Let's do a poll. What do you want to hear next?
Yes, that's a good point. So, gentlemen, what do you want to hear about next?
Yeah, I can highlight maybe the biggest problem what I see with Java and AWS. Let's assume you have a service like Spring Boot REST-based service, and you're running it in Docker or in EC2, ECS, whatever. And we have this problem in production. And your task or some pod can process, let's say, 1,000 requests per second when it's like already optimized by JIT compiler. So when it processes like several thousand requests. But when you scale it, add one new task, and you have a real production system, it has a huge load, new task will be crashed due to because it's not optimized, it just started, it cannot work fast. And there is no good solution. The only solution, what I noticed, it's like use service mesh and do not send all traffic to these pods, but it's very difficult to control. And nobody knows how to solve it. This is like big hell. So, for example, if you're using Golang, you can compile and use like ahead of time compilation. It will not have this problem. But with Java, you, for example, cannot scale it. It's a big problem.
You're right. Would you mind making a call? Making a talk about it?
We can talk, but there's no solution. We need a good solution, or we can discuss the problem. Maybe to have some brainstorming. I don't know.
Yeah, why not? Okay, so anything else? If not, thank you very much for joining. Hope you enjoyed the session. It was at least a little useful for you. Have a happy Friday and have a great weekend. And I need to
Thank you, Alexander. Very great
Thanks a
session.
lot.
Thank you, Alexander.
Thank
you
you.
very much.
Bye.
I'm not so prepared, but I appreciate it very much. Thank you.
You're welcome.